So the next issue we're going to talk about the major issues, challenges in data mining at this time. Um, so um, from the perspective of mining methodology, um, with accumulation of different types of data, we need tools to mine various and new kinds of knowledge. At the very beginning, as you probably noticed, data mining started from large databases, and then it moved on to the web resources and streaming videos and other new um, type of data, social networks, and all those methods, all those new data type demands new mining methods, right? And also mining knowledge in a multidimensional space remains challenging. One observation is when you have data represented in a very high dimensional space, um, you will have to collect a lot of more training example in order to cover this multi-dimensional space for the algorithm to learn good models that can actually work in this multi-dimensional space. The curse of dimensionality remains challenging, and we're going to spend time in this class to explain what is the curse of dimensionality and why it affects performance of various machine learning algorithms. A lot of algorithms works very well in low dimensional space, but works really poorly at a high dimensional space. Especially for clustering algorithms. We're going to talk more about that later. Data mining, as we earlier showed, is an interdisciplinary effort. So interdisciplinary asks how different disciplinaries contribute, and the methodology from different disciplinaries can be integrated as a whole to address data mining issues. But at this time, data mining is more of a multidimensional effort that we have many efforts from different disciplines that work on problems that's specific to that discipline. So we need more integration of different different disciplines to collectively work on data mining challenges. Um, Boosting power discovery in a networked environment. When we have large networks, when we have huge amount of data, a lot of traditional statistical methods will stop working. We will need high performance computing support. So in that regards, many algorithms have to be modified so that they can be distributed and work effectively. Instead of having to wait for months for a result to be returned, we want the result to be returned in a day, maybe. Handling noise, uncertainty, and incompleteness of data is also challenging. This is a long-term issue. So when we collect the data from the world, it is just really so typical that the data cannot be complete. There always be missing data. Sometimes critical data is missing. That creates problem. And sometimes data are hard to collect, so we don't have enough training example. That require us to figure out other ways, other learning schemes that allow us to use smaller amount of examples to mine useful information. And also noise. And earlier we talked about outliers. Outliers and noise are different things. Outliers are something that's interesting, that could be interesting and answer our key questions. Noise are just coming with the data. Any data collection methods will have systematic noise or random noise and we need a way to clean those noises. And sometimes it's hard to differentiate noises from outliers. How do we know this data point far away from other data points is not an error in the data, it's not a noise? Or maybe it is a real truthful data point that is just an outlier. We don't have a very useful operable way to make those to differentiate noise from outliers in many situations. So that remains a challenge. Pattern evaluation, um, pattern or constraint guided mining is challenging. So earlier we used association rule mining as example. It remains hard. You have this many different metrics to allow you to see the best smaller number that you think are the best patterns. But when we do exercises in this class, you will be able to appreciate pattern evaluation is not about a number. How to find real useful patterns in hundreds after you perform all those filters and rankings from hundreds of patterns are still very challenging. Constraint guided mining is interesting because a lot of times we put this mining task into a clean model and we ignore other factors. We just concentrated on a clean set of factors to run our mining task. But by ignoring realistic constraints from the real world, it limits the application. Um, so if the research going on to help, for example, how can we modify this algorithm so that we promote recall and we don't care about precision. We just want to discover everything that might be a terrorist, for example. Everybody that might become a terrorist. We don't then we can actually work with all those people and help them. We care less about whether the system is really accurate, but we wanted to discover all the potential risks there. For example, medical diagnosis and those other applications have special constraints. In order for the algorithm really help us to provide real-world solutions, how can we develop flexible ways to allow the algorithm to incorporate real-world constraints is another challenge. From user interaction point of view, interactive mining is actively is a very active research area where the user interacts with the mining systems and guiding the mining systems. Humans' input are very important in many mining scenarios. People with domain knowledge can certainly guide association rule mining to avoid lots of unuseful rules to be mined. Incorporate background knowledge. When we talk about Bayesian networks, we will see that existing knowledge can really help. We can learn lots of probabilities from the data, but when data is not sufficient, when certain areas is not covered, and we have human knowledge there, if we could combine them, it will certainly improve the overall performance of the system. So user plays an important role. Presentation, visualization of data mining results is a long-term challenge. When you have the mining task is basically to condense a large amount of data into knowledge, and we want this knowledge to be intuitive to a user. So visualization allows that to happen, but when you have lots of data points and a lot of correlations and other kind of relations, visualization can be challenging. So visualize the data itself or visualize data mining results are both active research areas. Other things in data mining, we always improve efficiency and scalability. Scalability talking about how much data we can process. Efficiency talks about how quickly the program can end, whether program ends at all. So we can use parallel distributed um, computational infrastructure to support those. Those are always ever developing. Diversity of data types, I think we talked about this earlier. Data mining and society is also a very important area. And this is the area that I personally feel like social scientist has not been integrated into data mining process often enough. So that study social impacts of data mining is critical for the future of data mining. To what extent we can trust the data mining result if the mining result is not interpretable by human? How can we make critical decisions using those results? Privacy preserving data mining is another active research area. When we do mining, how can we preserve that privacy? The problem is not as simple as just removing your name or birthday. Other information collected by the system can actually be used to identify individuals. And if you think data sources, you have data left in different area. Every day you pick up your phone, you leave lots of traces of data in different apps. If those things aggregate together, the chance is very high that the data collected by various electronic systems can actually uniquely identify a person. Privacy preserving data mining is, is, is completely necessary, and it's very active. It's a very active research area. How can we and invisible data mining is probably, well, because it's invisible, so we don't know what mining occurred. I have a note in an earlier slide. Invisible data mining refers to data mining functionalities being built into regular functional components. So, for example, when you read news articles, data mining already performed all those analysis, pushed all the news that you wish to look at to your device. I personally feel that really narrows our view of the world. We've always been fit the news that we like to see, and our um, 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 world value was just limited to what we already know. So that could be a side effect. But invisible data mining is will only be more and more affected our life without us actually being aware how to what extent that we have been affected by those. So generally speaking, I feel like the book covered a broad range of the major issues in data mining. When we talk about specific algorithms, you're going to see the weakness and strengths of different mining algorithms. There's not a mining algorithm that works for all data sets. And some of those points that we discussed here, for example, dimensionality, going to be reflected in our future discussion. Okay, thank you for your attention. I think this is the last video I will make for this chapter 1. Let me know if anything's working or not working for you. If there is a problem, I would like to fix them sooner than later. Thank you.